Okay, today I will talk about how the circulant matrix gives rise to the DFT, or discrete Fourier transform. So first we will look at S and S conjugate. Actually, S is right circular shift matrix. We'll talk about S conjugate in a moment. So what S does is that if it works on a vector x, it actually, let's say first x is equal to x naught, x1, and so on, xn minus 1. So it's a length n vector. So if S works on x, so if you multiply S with x, the vector x, then what it does, it gives us this kind of a vector. So what it's doing is that it's actually circularly shifting the vector x to the right. So we can see that x naught has gone here, and the last element, x of n minus 1, has circularly shifted or rotated back to the position 1. So let's actually work with column vectors. Okay, so what will be the shape of S? So we can easily get the shape of S. Let's say that's S, and let's say we are working with a 3-element vector. So we want our vector this way, x1 and x2 here, that would be 2. So we want here in the first row x2, so that would be 0 0 1. We want here 0, so 1 0 0. We want here x1, so 0 1 0. So there's our S. So based on this 3-element vector, we can actually expand S, and we will get S, the matrix S, like this, all the way to the 0, then 1, all these 0, then 0, all these, then 1. No, I'm sorry, that's 0, that's 1, and so on and so forth. So here would be 1 0. So that's our general S. So here if we take S conjugate, actually conjugate as all the members are either 0 or 1, so S conjugate is just S transpose. So if we multiply S transpose with the same vector x, you can easily verify that it will actually left shift. It will left circularly shift the vector x, and you can also verify that S conjugate is actually that matrix that is circularly shifting the vector x to the left. So now we will define what a circulant matrix is. So what is a circulant matrix? A circulant matrix, it has the form of this. So the first row, the first row of the circulant matrix is this. Then the first column is this, let's say. So well, I'm sorry, if the first row is this, the first column cannot be this. Let's write again. Let's say the first column is this vector. So for a circulant matrix, for a matrix to be circulant, the second column is just shifted right, the operation we just saw, this way. So the second column will be a right shift of the first column. Then again the third column would be again, sorry, that would be n minus 1. The last element will be rotated back to the first position. Then the second column is this way, dot dot dot, all the way to x naught. This will go all the way to x1. This will be x2, dot dot dot, so xn minus 1, and so on. So this is a circulant matrix. Next, we will see some properties of the left and right circle shift matrices S and S conjugate.